welcome everyone, those who are here in the room and those who are attending online. I'm Francesco Bosello, Professor of Economics at the University of Foscari, Venice, and I'm glad to introduce today's presentation held by Denitsa Angelova. And the topic of the presentation is something that is quite a quite popular topic and also hot topic in the recent time, that refers to the relation between climate change risk and also some risk that is more related to the let's say budget sustainability of countries, what we call in economics sovereign risk. This presentation would be more focused on constructing a climate change risk index as the first step of the study, that then would like to explore the connection between climate change and sovereign risk. However, I guess that in the presentation there will be also some comparison of this index that has been built following some rationale, robust rationale based on a quantitative methodology. So the comparison of this index with the index that are used by rating agency to show more or less the pros and the cons of different methodologies. This is a 2-year work, so there is a lot of work, and we are very glad to have Denitsa to present the still preliminary but also quite a well-established result of our research. Denitsa, the floor is yours.
Thank you, Francesco. Hello, as I said, I'm Denitsa Angelova. I'm going to be presenting the results of 2 years of our collaboration. The motivation of our study is the following. Okay, so we definitely saw that the 3 big rating agencies, Moody's, S&P, and Fitch, are using some kind of a measure for climate risk or environmental risk in order to augment their sovereign risk assessments that they publish every year for maybe something like 50 years. Those are usually published in the form of ESG protocols that then correct those sovereign risk assessments. We also browsed through the ESG protocols and saw that the measures that they're using to quantify what is essentially climate risk very much deviates from what the IPCC would define as climate risk, both in the assessment report number 5 and the 6 that is actually about to be finalized now and to come out. So their definition of climate risk and what the IPCC actually defines as climate risk are 2 very different things. So what we actually then set out to do is to construct a risk index, climate risk index, that is number 1 grounded in the IPCC definition, as it is understood now in the 5th assessment report. Number 2, it is based on quantitative information, not on qualitative measures, because this was partially what the rating methodologies were doing. It is also transparent to everyone coming from the outside, so you don't really need the exact expert to replicate the results. And it is also replicable, so that everyone coming from the outside can actually take our methodology, download the data, and see what happens. So this is what we set out to do. This is the definition of climate risk as the IPCC understands it from the 2014. According to it, climate risk is defined as an interaction of hazards, exposure, and vulnerability. And vulnerability in itself is composed of adaptive capacity and sensitivity. And I'm going to show you in a second what exactly you should picture under this very nice Venn diagram. So, for instance, very short example: a sovereign is exposed to climate risk, and the hazard, for example, would come from something like extreme temperatures that are increasing, or there is actually a promise to extreme temperature. The exposure of a sovereign would be actually greater if there is more agricultural value added that is exposed to this extreme temperature. Here we see, of course, the crop fields and the cow, for instance, to represent the agricultural sector, which is very prone to hits from climate change. The sensitivity of a sovereign would be given, for example, by its reliance on the agricultural sector as a part of the GDP. So the more a sovereign is reliant on the revenues from the agricultural sector, the more sensitive it is to the climate risk. And the adaptive capacity of a sovereign can be affected by the GDP per capita, for example. And the more rich a nation is, of course, the more capable they are to adapt to climate risks. So those 4 dimensions of climate risk interact somehow with each other to build the final climate risk that is typical of a sovereign. So we use a climate risk assessment model that is based on a composite indicator, which actually means that we hypothesize that climate risk is made up out of different dimensions. The types of climate risk have been identified by experts, as well as the indicators that were used to substantiate this thinking empirically. So we have deduced also based on literature that we have physical climate risk that stands from mean temperature increases, extreme temperatures, droughts, floods, and health risk. Each one of those climate risk types has an associated hazard, exposure, sensitivity, and adaptive capacity. And each one of those hazard, exposures, sensitivity, and adaptive capacity has some indicators that empirically substantiate the whole exercise. And you'll have to excuse me for the next 5 slides, in which I decided to very last moment to show you all the indicators so that you have, I could tell them to you, of course. I can also write them down so that you know for sure what we're talking about. For mean temperature risk, we are talking about changes in mean temperature as a hazard. The exposure is given by total population. The sensitivity of a sovereign to mean temperature risk is given by biodiversity loss, share of urban population, population growth, and Gini. And the adaptive capacity for mean temperature risk, as well as for the other types of risk, is given by the quality of institutions, the education, the GDP per capita, and the access to basic services. For extreme temperature risk, the hazard is given by changes in heat waves. And the exposure is not total population, but urban population. The sensitivity is, of course, given by the young ones and the old ones that actually disproportionately react to those heat waves, as well as the share of the urban population, because cities are much more vulnerable in those circumstances. The population growth and the Gini remain there, as well as the adaptive capacity, which again is given by the quality of institutions and education, GDP, and access to basic services. For the drought, we have the changes in the number of droughts as a hazard. We have total population and agricultural value added as the exposure. And then the sensitivity is made up of many components. Number one, the percentage of agricultural value added to GDP, the population that is young and old, the share of urban population, the population growth, and the Gini. And the adaptive capacity remains the same. The flood risk, of course, the number of floods. And here in the exposure, we have the population in low elevation and coastal zones, and the population in floodplains. Conversely, of course, the sensitivity is the share of those things. And for the health risk, I'm going to guide you to it so that it becomes repetitive after a while. The hazard is given by the changes in malaria suitability, and the exposure is given by total population. The sensitivity is made out of the share of urban population, the population growth, and the Gini coefficient. The adaptive capacity remains the same. Okay, so I'm through. This is what we have. It's about 50 indicators that we have collected from various data sources for the last 20 years. And those data sources include the World Bank, the European Center for Medium Range Weather Forecast, the Emergency Events Database, Lancet Countdown, the World Income Inequality Database, our World in Data, and last but not least, of course, NASA, that provide quite a lot of information. So once we have already identified at least one indicator for each climate risk type and climate risk dimension, we use a combination of weighting and aggregation procedures to somehow come up with a final assessment and a sovereign level. And the computational steps are very quickly, we'll go you through them, the following 4. So first we take the indicators, we normalize them. So this is a normalization within the data range. As a second, we obtain a hazard, exposure, sensitivity, and adaptive capacity for each of those climate risk types. Here I have put, for example, the simple averaging. We have, of course, conducted a lot of experiments in terms of normalization and averaging procedures. At the third step, we of course take those values and obtain a climate risk type value by the following formula. The climate risk, hello Silvia, just in time, the mathematician arrived. So the climate risk is made out of hazard, exposure, sensitivity, and adaptive capacity by the following formula. The climate risk for a specific type of risk is made out of the square root of hazard times square root of the exposure over this fraction over here, 1 over 1 plus k, 1 plus k times sensitivity, 1 plus k adaptive capacity. And this part is the vulnerability. This parameter k is something that we put inside of our assessment, and we have conducted, of course, sensitivity analysis with respect to it. It shows us the maximum reduction possible in the risk measure at maximum adaptive capacity and minimum sensitivity. So it is, in a way, it is a measure of the extent to which hazard and exposure can be mitigated by the vulnerability component. As a fourth, when we actually have then a measure for each of the sovereigns for each climate risk type, we obtain a climate risk index for each one of the sovereigns via the OVAR procedure, which stands for ordered weighted averaging. And I hope that I do not offend the mathematicians in the room when I say that the non-technical description of OVAR is more or less the same. The following, we have, this is a procedure for weighting numerical alternatives. In first step, you order them from highest to the lowest, and then you apply the weighting. And what is a little bit different from the common averaging procedures is that the weights are associated with the relative position of an alternative in this ranking rather than with the alternative itself. And those type of weights reveal something about the preferences of the decision maker. So to give you a little bit of an example, we have in this case 5 sources of physical climate risk. We have mean temperature, extreme temperature, water flood, and health. And this is what the vector of overweights could look like, 1, 0, 0, 0, which would actually mean that the decision maker only is looking at the highest possible risk for a specific sovereign. This is his preference. He simply says the risk to me, to a sovereign, is the highest possible risk that could occur. Of course, there is different preferences that are accessible to a decision maker. He could also say, I want to look at the average risk. So I don't only care about the heat waves. You know, I'm not catastrophizing, for example. This is what he could say. I'm looking at the average. So they might be prone to heat waves, but the rest is actually pretty low. So I'm happy with that. I would give this sovereign a lower ranking. Anyway, so this is another type of parameters that we put into our analysis, and we have conducted also sensitivity analysis here to what extent the preferences of the decision maker change the position of sovereigns. So, for instance, this is this is the example. We have a mean temperature risk of 0.4, extreme temperature risk of 0.5, drought of 0.6. Float of 0.3 and health of 0.4, and in this kind of this decision maker over here would say, I'm only interested in the droughts, in the highest possible. The rest is of no importance to me. Okay, so the results. I'll answer, if it's actually okay, I will answer the questions at the end. We'll answer the questions at the end. Okay, so we have selected a benchmark scenario, which would correspond to a K of 0.25. This would be 80% maximum reduction in the risk measure coming from the vulnerability factor. And in our benchmark scenario, the decision maker applies an averaging. So he's interested in the average of those climate risks. So we immediately saw something very strange and checked twice, 3 times, 4 times. We saw that the exposure component numerically dominates everything else. So we have tried, and this is one of the big results of our study, is that when we apply rigorously the definition of the IPCC with the measures that you would commonly attach to it, or to quantify exposure, you would see that countries with large populations, of course China, India, and the usual suspects would score very high. Of course, this would also mean, and this is against common wisdom probably, that the small island countries would score very, very low. This is, of course, but this is something that actually comes from our analysis and applying the IPCC definition of climate risk, as it is actually now, in the assessment report number 5. Okay, for the individual types of risk, we see for the mean temperature, for example, we have the exposures still dominating the rankings. We have China, India, Pakistan, Afghanistan, and Bangladesh. Sorry about voice, India, as scaling very high in the ranking, as well as some African countries, Sudan, Niger, Uganda, Chad, Nigeria, Burkina Faso, Mali. The least riskier, of course, again, those small island countries, but we also see here Iceland and Luxembourg. So it is actually clear that the exposure is driving the whole exercise for the mean temperature risk. The extreme temperature risk, we see a couple of countries in Europe, especially here in the northern part. We see Poland, Belarus, Denmark, Russian Federation. So we have where we have heat waves, as we saw last summer, that Europe was actually frying, even though we have shifting that it's relatively safe from climate change. We also saw, of course, a couple of African countries that were very prone to heat waves. In the least risky countries, we could not see that clear of a scheme of exactly what ended there. With respect to the drought, we have the East Africa very, very strongly affected. Of course, Rwanda, Uganda, Burundi, the usual suspects. Again, Mozambique, Ethiopia, and Kenya as well. We have Saudi Arabia, Afghanistan, and Pakistan as well, and a couple of countries in Central America. The least risky countries are those in Northern Europe, with respect to drought risk at least, and some small countries such as Sao Tome and Principe, Qatar, and Luxembourg that simply have very few of their GDP coming from agriculture. They barely have agriculture, therefore their score is not very prone to being risky in that way. With respect to the floods, we have a clear, unfortunate winner, so to say. The most risky countries are, as we saw in Pakistan. So India, China, and Pakistan unfortunately lead the ranking very convincingly. We have Brazil, Austria, Kenya, Angola, and Mozambique as well, and the landlocked countries tend to score very low. The health risk, again, is driven mostly by population. So we have big countries with a lot of population being, of course, very prone to diseases. The least likely countries are, of course, the small ones with small populations. And we're talking about population, we're not talking about the size. Okay. So with respect to the sensitivity analysis of our results, here on the left, you see something that looks like a donut. This is the distribution of the rankings, and the variability comes. So here on top are the most risky countries, according to the median. We have here China, India, and Philippines, Pakistan, Afghanistan. And very low, we have the small countries such as Vanuatu and Sao Tome and Principe. In a couple of hours, that actually Luxembourg and the likes. So the variation within this picture with respect to the total climate risk ranking comes mostly in the middle. We have a very stable top and very stable bottom. This is regardless of the values of the parameter key, which gives the maximum reduction that was possible in the measure due to the vulnerability factors. And regardless of the preferences of the decision maker with respect to which risk is actually, whether or not the maximum risk is seen as the only relevant or not. So we also see that we saw that the rankings are exposure driven in a non-linear way. Of course, this is why I'm not showing you some lovely graphs. We did that by simply removing variables and seeing what will happen, which is necessary when you use something like OVA, because for each country, of course, it's a non-linear algorithm that comes up at the end. But if it is actually an exposure-driven ranking, of course, the big countries are going to score on top and the small ones are on the bottom. We also notice that as exposure actually sinks, and usually this is with population, the role of the K increases. Okay, here we have a depiction of the climate risk scores for the 5 types. We have the scores for the benchmark. The benchmark again was K of 0.25 and equal risk valuation. And I have attached exactly this kind of a picture because under equal risk valuation, you would simply add up the different type of climate risk scores to come up with the final measure. So if it's not equal risk valuation, it will not be representable directly in a picture. But we see here from this picture that the sum of the mean temperature risk, which is here seen in blue, and the health risk, which is here seen in green, in dark green, dominate the entire climate risk ranking. So this is, and they're exposure driven. This is the total population now. So we compared, this is okay. We came up actually with a ranking, and the question is how exactly does it compare to what already exists? We have, for example, the ND-GAIN, which is the industry standard with respect to climate risk. We have the ESPON index, which is very popular in Europe. And we have, of course, the S&P ranking. We first identified potential sources of divergence between our climate risk index and what is already there. And we identified that the divergence could come from the different types of countries, or in some cases, like in ESPON, which is a regional index, the different geographical granularity of the index. There could be differences in the temporal coverage, and of course, there could be also differences in the ingredients that were used to come up with the index. So we compared it, and we found out that the full version of our climate risk index provides very different results from all three of the indicators. And we started playing around with the different types of, by switching off components. And we found out that when we switch off our hazard and exposure components, so we leave only the sensitivity and the adaptive capacity, we can largely replicate the ND-GAIN and the S&P results. The ESPON index was a little bit more difficult to replicate, but there could be a lot of issues due to the fact that the granularity is indeed so different. So when we were downscaling our index, we could not quantify the mistakes that we necessarily make. So to summarize, and then of course I would like to interact with you quite a lot, and hope that I get a lot of questions. The total rankings are driven by exposure, which actually means that countries with large populations score high, countries with small populations score low. The mean temperature risk is again exposure driven, so that large populations actually mean a lot of risk. The extreme temperature risk, we see a lot of it in Northern Europe and in Africa. The hotspots for drought risk are East Africa, Southwest Asia, and Central America. The flood risk is very pronounced in Southeast Asia, Brazil, Australia, and the South African coast from the both sides. And for the health risk, we have exposure driving the ranking, which actually means large populations, a lot of risk. With respect to the summary 2, of course, is that the exposure component dominates the ranking. If you apply the IPCC definition of climate risk, we applied the sensitivity analysis and saw that the majority of the top and the bottom of the rankings is very stable. We compared our index to what is existing and saw that transparently applying this definition of the IPCC leads to different results. We saw that the ND-GAIN and the S&P results can be largely replicated if we switch off components of our index and simply go with parts of it. We also saw, so through a lot of trying out, that the common wisdom concerning the climate risk of small island countries could be replicated under a very specific preference. So if there was a preference of the decision maker that looks at the largest risk, then Vanuatu would come on top. Yeah? There is actually a possibility with our index, so that this common wisdom of small island countries can indeed be replicated, but it's a very specific one. It's a very specific preference of the decision maker that makes the evaluation of what is risk and what is not. Okay, thank you for your attention, and I hope that I get a lot of questions and we can start interacting.
Thank you, Denitsa, for the presentation. Let us open the floor for questions. Let me see if
there is one.
Yes, there is one message in the chat, but not necessarily a question. Exactly. So. So we can open the internal debate, or if there are questions from the room, and of course we shall be very happy to collect questions from our audience. So you can write on the chat and we can see the questions. So
I believe you mentioned at the beginning that you have been collecting data over the past 20 years.
Yes.
So and you mostly show static results. I was wondering whether you also look at the evolution of standard risk.
We unfortunately were not necessarily capable of doing that because for some African, especially for the African countries, you usually have one value for the last 20 years. So this is we decided for now to not. This is true. This is true. But for the time being, our first results we're simply relying not in consideration but on data that already exists somewhere. But yes, in theory, you could do something.
Can we go back to the formulas, maybe page
Yes.
30?
Okay, so
Page 13, I think.
Mm-hmm.
Share screen. Share.
yes, okay.
So I don't know if I have missed something. How is the value K determined?
The value K was imputed, so we did a sensitivity analysis with 5 different types of K. In the future, we would like to elicit preferences from a decision maker. So we would like to make expert interviews. For now, this is only an exercise.
So in equation 2, it is simply the average of the axis. There is no weight to some specific factors. Right?
No, in the second one, this is actually straight up averaging. We tried also topsis, for instance, which is already some kind of a way.
So each factor is assigned equal weight.
Yes. Yes.
No, yes, for now,
For
and
now.
it depends on the level of the aggregation because there is a nested tree of indicators that build the final. So at the bottom level, we assume that an equal importance, and therefore also a standard averaging procedure. But at the upper level, there is indeed a sort of weighting procedure.
And sorry, I have another doubt regarding the temperature risk. I think maybe you mainly consider the impact of high temperatures, but maybe in some cases low temperatures can also be a problem. Have you considered that?
Low temperature, I must say that we have not so far. I have not seen it that much in the literature, but maybe Francesco?
So usually you are expected to see less and less episodes of extremely low temperature, if this is what you mean.
Because, for example, last winter, I think it's colder than usual in some places. It can be harmful and can cause damage to agricultural or economic activities and so on.
No, yes, that's absolutely true. Yeah. But the point is, if you want to detect the fact that these events are increasing or decreasing over time, so typically the number of extreme cold events is projected to decline. So I'm not saying that they are perfectly complementary, but by taking into account how much but we are recording, but how much the extremely warm temperature events are occurring, we are taking also into account that perhaps we have less extreme cold temperature events, even though it's true that we didn't include that part of the analysis.
Can I continue that discussion? Just wondering why you would want to not include factors that would go down with the changing climate, like respiratory infection or these cold events, because actually in reality there's more deaths related due to cold events than there are to hot events. I'm just wondering why you would want to eliminate those from the analysis.
Okay, no, we didn't decide to eliminate. But by the way, you notice that our health index is based on malaria suitability, let's say. So it's a very partial dimension of health. So we started to consider that was also that depended on the data that we So you can find good data on malaria suitability under the environmental point of view. No, the point is that we are analyzing the risk index. So initially we focus on those variables that are describing the increase in the index, basically, but was not really on purpose to exclude other types of indicators. As usual, one can say, okay, but you should have added that, or so. Is always possible to improve, adapt, enlarge.
Answer the question. I have one.
We have a question from the audience. Do you see any potential application at the corporate level? Do you think it can be applied for risk assessment of stranded assets, or the data are too coarse? Okay, this is for you, Denitsa.
There are commercial tools available, but methodologies and data on which they rely are always unknown. I'm not sure to what extent, corporate level for stranded assets, I would actually go a little bit down geographically. I think that our measure at the sovereign level is a little bit too crude. For instance, when you see the one value for China is a huge country, so you could apply the methodology, of course, if you find sufficient data at a regional level to feed it, then you can definitely use it for stranded assets and risk assessment. But as it is now, I would say that in majority of cases, especially for large countries with a lot of deviation, that it would be too crude.
Yes, the idea, if I may add, the idea of the index is to be applied at the national level. Yeah. That is for countries. And the idea was also to compare with what is currently being done by rating agencies. So this is our, let's say, framework. With the corporate, quite a different scale of analysis is required. Let me also say that for the stranded asset issue is mostly related to policy dimension. So you have you need to change your production structure, you need to decarbonize because there is a policy that imposes you to do that. And so if you are heavily relying upon fossil fuel, fossil intensive production system, then you may lose your investment, let's say, in a good way. Okay. Here, the focus is more on the physical risk. Yes. So we don't really have here the policy dimension, even though part of let's say, there are some institutional factor as component of the adaptive capacity. But here the idea is really to focus on the physical risk dimension. With corporate, it can be relevant as well, because if you are investing in a sector which is highly climate sensitive, you can have stranded assets as well, because there is a risk that destroys your supply chain or your main input for production. But I mean, the stranded asset is more related to the policy dimension, so slightly parallel to this to our research.
It's transitional risk and not physical. Thank you. I hope that we answered the question.
I have one if nobody else.
Please.
First of all, thanks for the very interesting presentation.
I hope it was.
Impressed how many variables you included in the vulnerability part. One thing that stood out there for me was places where there were risks that I didn't expect to see risks. For example, with your health, which I think you're just using malaria, the high latitude countries seem to show a high risk there, where I wouldn't expect malaria to even occur at all. And then also with the extreme temperatures in India, where we know they're well known that there's lots of heat waves there, and I would say the Ganges Valley, and you showed low risk there. So I was wondering why those are sort of opposite what I would have expected.
This is a very good question. Thank you. The reason why this one is actually happening is we're measuring the hazards is measured as changes in heat waves and changes in yeah, it's the change. It is not the total occurrence. You're right. So the total occurrence in India is still very high, but they typically have a lot of heat waves. So, and this is why actually you would see India as low risk. So it continues to happen quite often there. And we are sorry about this, but it happens indeed very often. This is why they are low. With Northern European countries, of course, I live in Germany. I can tell you that I started seeing species of mosquito I have never seen up there in the last couple of years. So this is why that actually could carry potentially diseases like that. So the changes in the suitability for the conditions for those diseases is what matters.
So I didn't catch you were showing a change. Can you say what the change was? What period you were comparing to?
So I think that the first data that we have are from the 2000s to 2020. And we made an average compared to a long-term average from the 70s. From the 70s until now.
The second stage of this research will be to conduct interviews policymakers, if I understand correctly. No.
We would like to now somehow try to directly correlate this kind of a measure of climate risk with the sovereign risk to see how risky countries become. For now,
there are two developments. One which is one which is more methodological. So keeping the same structure, more or less, of the index, we would like to now, refining, but populate and using more expert opinion to better tailor the index itself. Then there is a step forward that is, of course, we would like to test if this index and more in general climate risk has or not an impact on the credit worthiness of countries. So using some measure of sovereign risk that could be the rating, the evolution of the rating itself, or the debt over GDP ratio, the spread. But this will be the next. Okay. So we'll be in parallel. So refining the index and also applying to the analysis.
Okay, if there is, I'm also open to questions via mail. So if you want to ask me something, I live on Internet Street, or maybe Francesco, of course, who is one of our experts.
Yes, for sure.
How about in your vulnerability, would there be a way to include other factors like gender, or other, say, disadvantaged groups, and could be race related or gender related?
Mm-hmm.
Maybe you have the economics in there, but I don't know if there are ways to include some of these variables.
Yes, it can definitely be included. We also try to keep the number of variables manageable, because the issue of, for instance, the gender can be very different. So gender imbalance may have, or can have very different implication in different countries. For instance, we included at the education level. So that more or less should is not homogeneous, but should more or less represent the same thing in different. But yes, of course, that could be included. So, but the vulnerability part, which is sensitivity and adaptive capacity, is the more difficult and the more subjective also to be identified, to be defined. So it is also interesting that our index is quite similar, or reasonably similar, to other index when we look at the vulnerability part, because which is the more difficult to be defined. So it is as if the other index, more than risk, are focusing on the vulnerability of countries. Okay, so having less emphasis on the exposure and the other. So that was also an interesting result of the analysis. So coming from totally different methodologies, then if we isolate our vulnerability part, is rather similar to other indexes. So we are also trying to inspect a little bit more this dimension.
Yeah, to us this is actually a good sign. So if we can replicate already established methodologies that are widely applied, we consider this a good result. Thank you.
I have a curiosity really. So I find it interesting how you said that there's a possibility for you to kind of apply the weight of the importance a decision maker would give to different kind of risk type, right? And you said you assumed average, so is it like?
This is our benchmark, but we have 7 different types of weights.
Oh, okay. So did you see much difference
in the as we saw, and maybe I didn't because I was speaking too monotonously. At the top and at the bottom there is almost no reason. So China is always the most risky. China and India is always the most risky. The least risky are the ones with a low population. So at the top and at the bottom of the ranking you see almost no difference, and in the middle of the ranking we see this huge and this one comes from K and also from the overweights. More from the overweights of how the decision maker himself actually believes the risk to be related.
But sorry, you explained this when you show the indicators, for example, when you build the exposure. I guess for some hazard you use populations, for some other you use the agricultural land.
Yes.
No, I was just thinking about this result of the small islands. I guess it depends on the type of hazard that you consider.
It was the population. It was indeed the population. So the population drives the whole ranking. And the
population.
No, okay.
For the exposure. All of them are, so all of them.
Even drought risk, for example, probably is more related to, also related to the fraction of land that is used for agriculture.
Yes, that is the sensitivity part. That is the sensitivity. Okay,
it's like big agriculture, is like agricultural land exposed to.
Yes, no, okay. No, this is important. So,
yes.
The drought, the exposure are the square kilometer of land, agricultural land that can be subjected to drought. The sensitivity is the sensitivity is the share of agricultural land over the total land.
As it is
if
here,
you have a lot of, if you make, so one country can have a larger land, such area exposed, okay, but this area is a tiny percentage of the total land of the country, so it's highly exposed, but less sensitive. The same for population. The point with droughts is important to say that we cannot disentangle floods, for instance. We didn't disentangle the river floods from sea level floods. Okay, so, but even though you can find areas like China that have a very long coastline and that could be is more exposed than Vanuatu, because simply because China is much smaller. Then Vanuatu should be more sensitive, because the smaller part of land, of coastal land of Vanuatu exposed to sea level rise, okay, is a higher share of the total land of Vanuatu compared to the total land of China. So there is this difference between exposure and sensitivity. And this is also a key point, because when we decided to treat exposure, it's true that total population is not always the indicator of exposure in all the risks, but when it is for 3 out of 5.
3 out of 5. Yes.
Okay? And when you put everything together, this dominates. Okay, so
But dominates because of a weight.
No.
Yes, because everything is weighted, even though you don't put the weight, it is weighted because it is one. It's as if everything is everything is weighted, even though you are not weighting explicitly. Okay. No, the point is that then it is very robust when we check for the K, for the other way. No, the point is that we say that, and this is subjective that we treat, let's say, 2 people exposed to an event as the same person exposed twice. Okay, so this is the idea that we have here. Okay? So a lot of population makes
A lot of exposure.
Makes a lot of exposure.
True.
And everything is normalized, and also we also apply some smoothing of the effect to account for outliers, because otherwise China would have been always by far every time at the top, but much more so distant from the others, because of population.
Yeah, is population.
Now the point is that we are not claiming that our approach is correct.
Yes.
No, we say, okay, let's start from the definition of the IPCC. Let's try to do it properly. Let's see what happens. Because in the other index there is a lot of, first of all, it's not clear how exactly they have been computed. I'm not talking about the Notre Dame index, it's very clear, but the rating agencies, there are a lot of expert opinions. So in our case, it is transparent, and you can also reconstruct what has been done. So if we do this properly, we can get something which is different, much different. So I'm not saying that our way is better, because it can be more intuitive the other places. But yeah, we can also show when the 2 approaches are similar. So this is the
value of our work. Okay. Okay.
I think we are done with the time, I guess. Perfect 1 hour. So thank you again. Thank you again to you that were with us in the room. Thank you, Denitsa, of course, for the presentation. And thank you all to those who attended online. And of course, you are very welcome also to send us questions by email if you are interested in the development of the work.